Welcome children. Today we are going to discuss few board questions that is commonly asked from the chapter coordination compounds. Name the following coordination compounds according to IUPAC system of nomenclature. The first one, CONH3 4 times H2OCl. So its coordination entity is positive. So name the ligands first. Tetraamine, amine has 2M, aqua, chlorido, cobalt. Coordination entity is positive, so cobalt. Cobalt 3 chloride. Why cobalt 3? Because here NH3 charge is 0, H2O charge is 0, Cl is -1. Here you have -1 into 2, -2. So outside the coordination entity +2. So here cobalt should be +3 because +3 -1 only will give you +2 outside. Now let us go to the next. Here also coordination entity is positive. We start with the ligands first. Dichlorido, bis ethane 1,2-diamine, positive coordination entity. So chromium. What is the charge of chromium? Let us see here. Chloride Cl -1, 2 are there, so -2. Ethane charge is 0. Now here chlorine, only one chlorine -1, outside the coordination entity +1. So chromium should be +3. +3 -2 only will give you +1 outside. So put the charge of chromium in parenthesis. Chromium 3. So naming of coordination complexes according to IUPAC is one type of question asked. The next, the name will be given and you have to write the formula. That is the next type of question that is asked. Pentamine nitrito O cobalt 3. So central metal ion is cobalt. Open the square bracket, cobalt. Pentamine. So write NH3 5 times. Nitrito O. So you have to write ONO. If it is nitrito N, it is NO2. It is nitrito O. Now what is the charge of NH3? 0. What is the charge of ONO? -1. And here charge of cobalt is +3. Already given here. Charge is already given. So +3 -1 outside will be +2. Writing this +2 outside the square bracket is very important. Otherwise you will lose your mark. Now next question. Diamine, dichlorido, ethylene diamine, chromium 3 chloride. So central metal ion is chromium. Chromium, diamine. So NH3 2 times. Dichlorido, Cl2. Ethylene diamine, En. Now chromium 3 plus. NH3 is 0. Cl is -1. 2 are there, -2. Ethylene diamine is 0. So outside the parenthesis, you will get +1. If there is +1, only one Cl is enough. If there was +2, you have to write Cl2. So this is writing formula from the given coordination names. If you have any doubt in this, you can see my first video. Now let us go to the next question. Give the formula of each of the following coordination entity. CO3 plus ion is bonded to 1 Cl minus. So CO3 plus is the central metal ion. Open the square bracket. CO. 1 Cl, 1 NH3. 1 bidentate ethylene diamine. NH3 comes alphabetically first amine. So it should be written close to the central metal ion. How many are there? Only 1. The next alphabetical Cl, chlorido. So next write Cl. Next comes ethylene diamine. How many ethylene diamine? 2 are there. So En 2. Close the square bracket. Now CO charge is plus 3, NH3 is 0, Cl is minus 1, ethylene diamine is 0. So outside the square bracket, the charge will be plus 2. That plus 2 you have to mention. If you forget to write that plus 2, the whole question will become wrong. Look at the next question. Ni2 plus ion is bonded to 2 water molecules. So open the square bracket. Central metal ion is nickel, Ni. 2 water molecules. H2O. Aqua comes alphabetically first. Write that close to Ni. H2O 2 times. 2 oxalato ion. Oxalato in short is represented by OX. 2 are there. And what is the charge of Ni? Plus 2. Now oxalato, you write it as COO minus COO minus, right? Means it has 2 minus. Charge of H2O is 0. Charge of 1 oxalato is minus 2. 2 will be minus 4. Minus 4 plus 2 outside the coordination entity, minus 2. So this is the charge of the complex. This is how you represent the formula when they give you names. Now, next question. When a coordination compound CrCl3.6H2O, so let me mention it, is mixed with AgNO3. Two moles of AgCl is precipitate. What is the meaning of 2 mole of AgCl? When they say 2 mole of AgCl is precipitated, it means 2Cl is lying outside the coordination entity. Whatever lies outside the coordination entity will only react. Whatever atoms or ions which are in the coordination entity will never react. 2 moles of AgCl precipitated means Cl2 is lying outside. If it was 3 moles, Cl3 will be lying outside. If it was 1 mole, only 1 Cl will be lying outside. This point you should keep in mind. Now you write the formula, how the formula will be. Central metal ion is Cr. Among the 3 Cl, 1 Cl has gone out. So you have only 1 Cl inside. 1 Cl is inside means how many H2O should come? 5 H2O. Because 5 H2O and 1 Cl only will make the coordination number 6. The remaining one H2O, either you can put dot H2O or you can just omit it. So here, this is a structural formula, and what will be the name? IUPAC name, penta aqua chlorido chromium. Coordination entity is positive, so chromium. What is the oxidation state of chromium? H2O 0, Cl minus 1. Here Cl2, so minus 1 into 2, minus 2. Outside the coordination entity, plus 2. So charge of chromium will be plus 3. Plus 3 minus 1 only will give you plus 2. So put 3 in the parenthesis. This is the IUPAC. Such questions can come for even 2 marks. Okay, children? So only one thing you have to keep in mind. If there are 2 AgCl precipitated, then write Cl2 outside. 1 means just Cl. 3 means Cl3. Accordingly, adjust the charge and water molecule. Okay. Now let us go to the next question. Describe the shape and magnetic behavior of the following complex. They have given you 2 complex. When you say coordination number 6, the shape is going to be octahedral. No doubt. Whatever be the hybridization, if the coordination number is 6, the shape is octahedral. Now, next, magnetic behavior. To know the magnetic behavior, we have to check the hybridization. So, cobalt, the electronic configuration of cobalt is argon 3d7 4s2. Charge of cobalt is plus 3 because charge of NH3 is 0, outside 3 plus, so charge of cobalt is 3. Remove 3 electrons, 2 from S, 1 from D. So in 3D you will have 6 electrons. Arrange it. Now NH3 is a strong ligand. In cobalt, NH3 is a strong. We have already discussed this in my previous video. So pairing will take place between these two and between these two. So when pairing take place, no unpaired electron. Magnetic nature will be diamagnetic. Now look at the next complex, nickel. Here Cn is a strong ligand. You know that very well. Whatever be the central metal ion, Cn is a strong ligand. So Ni electronic configuration will be argon 3d8 4s2. Now what is the charge of Ni? Cn minus 1, 4 are there, so minus 2. So Ni should be plus 2. Plus 2 minus 4 will only give you minus 2 outside. Now remove 2 electrons. When you remove 2 electrons, the 3d orbital will have 8 electrons. Cn is a strong ligand, so these two will pair. Now the magnetic nature is what? Diamagnetic, because no unpaired electron. And what is the shape? Now look here, what hybridization will it be? One d orbital is empty and the coordination number is 4. For coordination number 4, two types of hybridization, sp3 or dsp2. Here d orbital is empty, so the hybridization is going to be dsp2. When the hybridization is dsp2, the shape is going to be square planar. If the hybridization was sp3, then the shape would have been tetrahedral. So here the hybridization is dsp2, so the shape is square planar. Now let us go to the next question. H2O 6 times 3 plus is strongly paramagnetic, whereas FeCN 6 3 minus is weakly paramagnetic. Explain. Now you can, if it is a 1 mark question, you can answer like this. H2O is a weak ligand, no pairing will take place, hence more unpaired electrons and strongly paramagnetic. Cn minus is a strong ligand, so pairing will take place, no less number of unpaired electrons, so weakly paramagnetic. Just you have to write this if it is a 1 mark. But if the question is for 2 mark or 3 mark, then you have to explain it. Fe, what is the electronic configuration? Argon 3d6 4s2. To know the electronic configuration like this, you should learn the order of elements in 3D series. So you will get it. Very important to learn the order of element. It will also help you in DNF block chapter. What is the oxidation state of Fe? Oxidation state of Fe is 3 plus 3. H2O is 0. Outside 3 plus, oxidation state is 3 plus. So remove 3 electrons. When you remove 3 electrons, you have 3d5. So let us arrange these 5 electrons here. Now you can see there are 5 unpaired electrons, so strongly paramagnetic. Now in the other case, what is the charge of Fe in Cn minus? It is 3 plus, because 3 plus Cn is minus 1, minus 1 into 6, minus 6. 3 plus minus 6 only will give you minus 3. Now if you remove the 3 electrons, you have in 3D 5 electrons. But the case here is Cn is a strong ligand. Cn being a strong ligand, what will happen? These two will pair and these two will pair. When these two pair, you have 2 electrons and 1 electron. Now you can see after pairing there is only 1 unpaired electron, which makes it weakly paramagnetic. So you have to explain like this if it is for 2 marks. 1 mark means only the writing part is required. Now let us go to the next question. Explain why CONS3 6 times 3 plus is an inner orbital complex, whereas NiNS3 6 times 2 plus is an outer orbital complex. If it is for 1 mark, you can say NS3 is a strong ligand in cobalt. Pairing will take place, which leads to inner orbital complex, because inner 3d orbital will take part in hybridization. Whereas in NiNS3 6 times, NS3 is a weak ligand, no pairing will take place, no 3d orbital will be available for hybridization, hence outer d orbital will take part in bonding, and the complex will be outer orbital complex. You just have to write if it is for a 1 mark. But if it is for 3 mark or 2 mark, you have to show the explanation. Look at this complex. Now cobalt is 3 plus NH3 is 0, charge of cobalt is 3 plus. Electronic configuration of cobalt is, remove 3 electrons, CO3 plus has the electronic configuration argon 3d 6. Now arrange these 6 electrons. Now you can see NH3 is a strong ligand. When NH3 is strong ligand, what happens? These two will pair and these two will pair. When they pair, what happens? You can see after pairing, the inner 3d orbital is taking part in bonding. So it is called the inner d orbital complex. It is called the inner d orbital complex. Now look at the next complex, NiNH3 6 times. Here electronic configuration of Ni. Oxidation state of Ni is +2. NH3 is 0. Outside the coordination entity you have +2. So Ni is +2. Remove 2 electrons from s orbital. You have argon 3d8. Now arrange these 8 electrons. Now NH3 is a weak ligand. In nickel, NH3 is a weak ligand. Here in cobalt, NH3 is a strong ligand. So being a weak ligand, no pairing will take place. So in the hybridization, it is the outer 4d orbital that will be taking part. So it is a outer orbital complex. Okay. Now we go to the next question. Low spin octahedral complexes of nickel are not known. What is low spin? Low spin means the number of unpaired electrons will be less. That is the meaning of low spin. So low spin octahedral complexes of nickel are not known. You can see the electronic configuration of nickel 3d8 4s2. Nickel can have an oxidation state of either 0 or +2. If you remove 2 electrons from 4s, then you have 3d8. So when you have 3d8, let me arrange these 8 electrons. Now if the ligand is strong, then these two will pair. When these two pair, there will be one empty d orbital here. Okay. This one empty d orbital cannot undergo d2sp3 hybridization. That is why low spin. Now the spin will be low, right? Because all are paired, right? But low spin, d2sp3 hybridization is not possible. So that is why low spin octahedral complexes of nickel is not known. If it is 1 mark, you can even write like this. Ni2 plus, even in presence of strong ligand, will produce only one empty d orbital. Hence, d2sp3 hybridization is not possible to form low spin octahedral complex. CO is the strongest of all ligand. You have seen in spectrochemical series, CO is the strongest because it creates a synergic effect which strengthens the bond between CO and central metal ion. One is sigma bond, which is formed due to the donation of an electron pair by CO to the central metal ion, forming a coordinate covalent bond. Also, it forms a pi bond when the metal donates a pair of electron to the antibonding pi star orbital of CO, forming a pi bond. So, because it forms a double bond, CO forms a double bond with the central metal ion, it is the strongest of all ligands. So this effect is called synergic effect. Now let us go to the next question. Explain the following terms giving a suitable example in each case. Ambident ligand. Ambidentate ligands are monodentate ligand with more than one coordinate site. Here SCN and NC is given. Another example is NO2. Here NO2, NO will be the ligating site. In ONO, O will be the ligating site. So NO2, N or O, either can ligate. Such a ligand is called ambidentate ligand. SCN, S can be the ligating site or N can be the ligating site. Okay. The next term, denticity of a ligand. The number of donor atoms in a ligand which forms coordinate bond with the central metal atom. If there is only one donor atom, then which forms one coordinate bond, then it is a monodentate ligand. If the donor atom can form two coordinate bonds with the central metal ion, then it is a bidentate ligand. Apart from these two terms, I have given large number of terms in my first video. You study all the terms, so any of it can be asked. It is knowledge level question. It is very easy to answer this. So I have explained, discussed with you all the type of questions that can generally be asked in board paper. Please go through this and learn the similar types of questions to get a better result. Please like, subscribe and comment. Thank you for watching.